Hi everybody. So in this video, I'm going to introduce you to integration, and we're going to consider this as the opposite of differentiation. So say we have an equation, y equals 2x plus 3, and we differentiate this with respect to x. So we'll get dy by dx is equal to 2. What we did here, so we brought this power down to here, and then we took away 1 from a power. And integration is the exact opposite of that, in the reverse order. We begin by adding 1 to the power, and then we divide by the new power. So if we were to integrate dy by dx with respect to x, then we should go from a 2 back to the y, 2x plus 3. And this makes sense because you can think of this dx and this dx as a division and a multiplication, and these two opposites would cancel. And then we've got the integral and the derivative, neither two opposites, and these will cancel. So we are left with the y. So if we were to integrate the 2 dy by dx with respect to x, when this is currently 2x to the 0, we add 1 to that power, becomes 2x to the 1, and we divide by the new power. And we know this is just 2x. So we have y is equal to 2x, but we don't have this positive 3. So what we do is we add on a constant of integration. And later in this video, I'll show you how to find this constant of integration when the y of a curve passes through a point. Okay, so in examples A, B, and C, we're going to work out each of these integrals. So the question A, this is currently x to the 1, so we'll add 1 to this power, and we get x squared. Then we'll divide by the new power of 2, and we'll add on a constant of integration. So a half x squared plus c would be the integral of x dx. Part B, to integrate this, we can find the integral of every individual term. So the integral of 3x squared would be 3x to the 3 divided by this new power of 3 plus 2x. Then we'll add 1 to this power, so it becomes 2x squared over 2. And this negative 1 becomes negative x plus c. And then for question C, we need to write this as a power. So we get the integral of x to the negative 2. Then we'll add 1 to this power. We'll divide by the new power of negative 1, and we'll plus c. And then we can tidy this up, so we get negative 1 over x plus that constant. Okay? Let's try another example. So for example 2, we've been told that dy by dx is 4x cubed plus 5x plus 2. We've been asked to work out y. So perhaps you want to try this question yourself. You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you had a go. So we need to find the integral of dy by dx with respect to x, because then these two will cancel, the integral and the derivative will cancel, and we're left with y. So when we integrate the 4x cubed, we get 4x to the 4 over 4. When we integrate the 5x, we get 5x squared over 2. And when we integrate the 2, we get 2x. And we need to add on that constant. And then we can tidy this up. So we get y is equal to x to the 4 plus 5 over 2x squared plus a 2x plus c. Okay? Let's try one more example. So in example 3, we're told that a curve passes through a point 112, and its gradient is given as this quadratic. We've been asked to find the equation of a curve. So we know dy by dx is this quadratic, then we need to integrate this with respect to x. So we'll get, this will become the 3x cubed over 3, we'll get 8x squared over 2, and this would become negative 9x plus that constant. Then we can tidy this up and we'll get... Okay, so now we've got the equation for y. We need to work out this constant term. But we're told that the curve passes through a point 112. So this 1 would be our x value, and the 12 would be the y value. So then we can substitute each of these into here to work out c. So we can work this out. So we get 12 is negative 4 plus c, so c is 16. Now we can substitute the 16 into here, and we'll get the equation of a curve. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and worksheet from my website, mrmathematics.com. I'll leave a link in the description below.